Hello, I'm Greg. Welcome to my channel, Midnite Oil Software, and another lunchtime live stream. In my last live stream over the weekend, I continued adding some preparation to my 3D space shooter tutorial game in preparation of adding multiplayer support. And over the weekend, I added a combination, using a combination of the strategy and factory patterns, I implemented object pooling for projectiles, missiles, explosions, and other effects. So today, what I plan to do is continue that preparation. The next thing on the list was to evaluate using ECS, specifically for asteroids, since there's so many of them, but I also wanted to determine whether ECS would be a viable solution for the floating point origin issue, whereas there's a floating point precision issue when players get too far from origin. That is, if they get too far from 000, things start to break down. You start to get jitter in the visuals, collisions can start messing up. You can run into different issues with trail renderers and things like that. And I had read somewhere that ECS could provide a solution for that. So anyway, I wanted to do that analysis, and I figured, why don't I leverage Bezi? If you've been following my tutorials, you know I've been using Bezi, which is a AI coding assistant that integrates directly with Unity. And the great thing about Bezi is it's trained specifically on Unity, and it can see your entire project. So it knows everything about my 3D space shooter project as it exists, and so it's able to make intelligent suggestions based on that. So I asked it to analyze where it would make sense to use ECS. I described the problem that I was trying to solve, both performance, like with having hundreds or even thousands of asteroids in the game, but also to examine whether or not it would make sense to use it for solving the floating point precision issue. And it actually did that analysis for me, and I'm going to go ahead and go over what it recommended. I'm going to show you here real quickly. If I look at my multiplayer guide start here document, I've got documentation for the overall implementation guide for adding multiplayer, and part of that analysis was using ECS. And I also wanted to reconsider my initial approach for multiplayer. So if you followed my channel, you also know I've developed a multiplayer boilerplate that you can install directly from my GitHub repo, and it will get you all set up with a lobby and relay system. You can do peer-to-peer games. You can get started like within minutes. I've got a sample Othello game, which is a turn-based game developed using that framework. And I also did a tutorial where I developed a multiplayer Space War game, which is a real-time space shooter type game based on an old arcade game called Space War. So both of those are using that boilerplate framework that I developed. But I was thinking about where I wanted to take this game, and I started thinking a peer-to-peer player-hosted game didn't really make sense. I was envisioning something that's more of a 24/7 hosted game server that players could just jump in and leave, and then maybe add some RTS elements to it. Like you could do some colonization, mining. You could have shipyards that produce ships. You could, develop resources and things like that. And you'd want all that kind of stuff to be going on even when you're not logged into the game. So I asked it to basically evaluate that and see what kind of architecture would make sense for that, and would it make sense to not even use my multiplayer boilerplate framework. So this is the result of that analysis. Key recommendations: we want to use ECS, but for asteroids only. It's going to explain why it doesn't make sense to use it for the player ships and projectiles and things like that. And it recommends that I implement a floating point origin system instead of relying on ECS. And it will explain why ECS doesn't solve the problem. And then it looks into my multiplayer architecture question and recommends using a dedicated hosted service using Unity Gaming Services, and to totally skip my boilerplate package for multiplayer. And I'm fine with that. I've already got 2 tutorials out there showing how to use that where it makes sense for a peer-to-peer game, but I want to do something different, something a little bit more exciting. So as far as the ECS analysis, it explains why it makes sense for the asteroids, because there's going to be a lot of them. And it explains the pros for that and the cons. And then it gives me some estimated performance improvement using it and what kind of effort is involved in doing that. And then why it doesn't really make sense for projectiles or for player ships. And then it tackles the floating point precision problem. And it describes the problem, the symptoms that you see, and then it looks at different comparisons. And the one it's recommending is implementing this floating point origin system where you basically shift every object in the game. So the player will stay basically at origin and then move everything around the player whenever they get too far away. Now, the immediate problem that I saw with this solution is in a multiplayer game, multiple players could be more than 10,000 units from origin, but they could be on opposite sides of origin. And what do you do in that situation? So I asked it to consider that, and it will consider that and give a little explanation of what to do in that edge case, which isn't really an edge case. I think it could actually be pretty common. It looked at another option. Well, it explained why ECS wasn't a solution. Apparently, it still uses 32-point floating point calculations, so it doesn't really solve the problem. And then it talked about world partitioning in zones, and it thinks that's overcomplicated and that I can solve this better with my floating point origin solution. So the recommended solution, use the floating origin with event-based architecture, and it explains the implementation plan here. And I actually am going to show you the actual implementation plan, the comprehensive implementation plan that I had Bezi generate. So then for the multiplayer question, it explains why having a dedicated server makes sense, how it would work, the pros, the cons, and then it even goes into some cost analysis and stuff of what it costs to have a server up and running 24/7, depending on the size of the server and that sort of thing, and the fact that you get $800 of free credits when you first start using Unity Gaming Services. Compares it to the peer-to-peer with lobby and relay and explains why that doesn't really make sense. The host has an advantage. It's host dependent. The game ends if the host leaves, although you can transfer ownership, but that just adds an extra complexity. How you can cheat because the host can modify the game state. Limited scalability. It's more complex client code, and there's extra latency. So it explains why that doesn't really make sense. So yeah, use a dedicated server and explains why. So I thought that was all really good. So the next thing to do is to implement the floating origin system. So even though it says, yeah, it makes sense to use ECS for asteroids, it's giving that a lower priority than implementing this floating origin system. So I think that's what we're going to tackle first. We are going to implement the floating origin system. And so going back to our document here, we're going to look at the, where is that document? Do I have a link to it from here? I don't think I have it here. But if I go up to here, you can see floating origin implementation. So this is the actual comprehensive implementation plan for implementing the floating origin system. So again, it describes the symptoms, why this matters, and then it gives you a solution. When a player moves more than 10,000 units from origin, it will detect the threshold. It will shift all objects by negative the player's position. So the player's now at origin, the world shifted accordingly. It tracks absolute positions separately for persistence. So the architecture design, there will be a floating origin manager, which is a singleton. There'll be an floating origin receiver interface, and then we'll have specialized handlers, a rigid body shift handler, particle system shift handler, trail renderer shift handler, and custom handlers for specific systems. It will be event driven using my event bus, use a singleton pattern. staged implementation. So this plan is broken up into incremental stages that we can implement a stage at a time. It's going to be multiplayer ready. So when we go to add multiplayer support, this should be well positioned to do that. It's going to be performance optimized with minimal overhead, and it should be extensible to add custom shift handlers. So the roadmap is first to go ahead and implement the origin system. We're going to create a new vector3 double struct, the floating origin manager, the shift threshold detection, and then the event. So that is phase one. Now, what I really like about Bezi is it doesn't just generate an implementation plan, but it can execute against this plan. So I also mentioned that I asked it to consider the issue with multiplayers being in opposite directions and why this could be a problem. If more than one player is beyond 10,000 units from origin, and it actually analyzed that problem and came up with some ways to handle that case. So I'm fairly confident that this is going to work. So here, like, it's telling me that players can be far from origin and opposite or far from each other. And so the solution is to use the average position, the centroid of all players, as the reference point. So you can still run into a little bit of issues where they're both kind of far from origin, but this should minimize the amount of shift and jitter and stuff that you see. And so this is probably where we're going to ultimately get to. But we're going to start with the incremental plan with phase one. So if I jump into Unity and I've got Bezi open, so I have a new thread here, and I've selected the floating origin implementation page, which has that implementation plan that we were just looking at. I'm going to make sure I'm in agent mode, and I am just going to say begin implementing phase one of the floating origin implementation plan. So we're basically going to be trying to do a little of what's called vibe coding. I want to make sure that I don't have any outstanding commits. I have some documentation that's been updated. I'll go ahead and commit that to source control. And that way, if I break anything, I can just revert the changes. All right, let's kick off Bezi and see what it does. I'll begin implementing phase one of the floating origin system. Let me first gather context about the existing project structure, particularly the event bus system and singleton mono behavior pattern. So it's going to use my existing architecture and pattern and try and stay consistent with that. So now he has the context. He's going to create the phase one implementation. So he's going to create the vector3 double struct, the floating origin events, and our floating origin manager singleton. And there's the vector3D struct, vector3D double struct. There's the origin shifted event. Oh, I like that it's putting it in namespaces for me. And it's putting it in a folder too. There's our floating origin manager. Looking for compilation errors. You know what would be really cool too is if I had it generate unit test. No compilation errors. Now it's going to create a prefab for the floating origin manager to make it easy to add to the scene. Ooh, so it's actually creating a game object in the main scene. It's going to create a prefab. It put it in my prefabs folder. It's going to create a test script to verify the system works correctly and update the floating origin implementation page to track our process. So floating origin test, it's a mono behavior. It's going to create a new separate progress tracking page. Ooh, cool. It's going to create a README. Verifying compilation still clean. One final summary document. So it's going to put that in pages. All right. Okay, so there's the vector 3 double, the floating origin manager, origin shifted event, floating origin test. So interplay mode, add floating origin test component to the player ship, use jump to distance button or enable auto move, and watch the debug GUI distance resets when the threshold is exceeded. And there should be no visual jitter during shifts. All right, so I'm going to say keep all because I have everything under source control. And I am going to examine the changes in source control first. So our floating origin test, the test speed is going to be 1,000, auto move defaults to false, move direction is vector 3 forward. So it looks like it's adding a button to my player ship that I can click to have it jump to the jump distance and then see if it automatically did the shift. So here's our event. It's got an offset, the new reference position, and the shift magnitude. Here's our floating origin manager, the shift threshold. I might want to increase that. Enable auto shift is true. We're going to have a reference object, an option to turn on our debug GUI, some private variables, public variables, really public properties. So we have absolute world offset, total shift, and distance from origin. Okay, so this might not work in a multiplayer environment. But if this is going to be part of the prefab that I can assign, assign in the inspector, yeah, that should not be an issue. This should never happen. Late update. This is where it's going to update our UI, I guess. So distance from origin is going to be the magnitude of our reference object's position. And if our distance from origin is greater than our shift threshold, then we want to perform our origin shift. And performing origin shift is going to calculate an offset, which is going to be negative our position, or negative the reference object's position. It's going to add the offset to the absolute world offset, shift all objects in that offset, raise an event, increment the total shift count, last reference position. It's going to save that off. Shift all objects. Yeah, I'm not 100% sure about this. I'm definitely going to want to do some extensive testing. Root game objects. Shift transform hierarchy. All right. Did it give me any instructions? That's not what I want to look at. So just to add the floating origin test component to my player ship. That seems to be all it wants, but it seems like I would have to So I guess this is just one phase of the whole implementation. But let me see if it ever added that player origin manager. It did not. Floating origin manager, there's the prefab. Reference object. It doesn't tell me what to put in there. Well, let me go to my player ship prefab. And add the floating origin test component. And I'll leave that false. And I'm going to turn off, if I haven't already, the enemy ship manager. I did turn it off. So I don't have to worry about them showing up. Okay. Where is my button? Shouldn't, oh, it's, no, it's not on the game screen. There we go. Did it jump? So look at my position in the transform there. can't tell that it did anything. Timer manager is complaining when I exit the game. I'm not worried about that right now, but I'll probably want to deal with that eventually. I want to add some logging so I can see if it actually did what it claimed it was going to do, because I couldn't tell by looking at the transform. It said, watch the debug GUI, distance resets. Oh, I think they want me to look at that GUI it was displaying in the game screen. Distance should reset when threshold is exceeded. Verify no jitter occurs during shifts. All right, let's test that again. All right, so where is it showing distance? So distance is currently 0. It doesn't seem to be showing, updating the distance correctly. All right, I need to ask it some questions. To test, do I need to add the floating origin manager? And if so, what should I assign to the reference variable? I also see that it will try to find a player to use as a reference. How will that work in multiplayer? It's very flattering. Oh. But it was not, it did not detect the player. Okay, so it's smart enough to know that won't work in multiplayer. So that'll be fixed in phase 4. But it did not so the tag is player, but when I was looking at the GUI, it did not show the player ship under reference. So let's test it again. I'm pretty sure it's not going to be there. Reference, none. All right. I also want to see, where did it put it in my hierarchy? Ah, it's way down there. All right, I'm going to put this up under managers. Cool. And I'm going to tell Bezi. He needs to subscribe to player spawned events. Yes, it saw the timer manager issue. No compilation errors. All right. Oh, good. It's going to update the documentation as well. I like that it's fixing the documentation because that basically gives us a running game state of what it's implemented so far. So if I exit out of Bezi, exit out of Unity, and come back in later, I can continue with the next phase, and it can see what's already been done. Alrighty. Alrighty. Okay, so my distance, you can see it's gradually growing as I'm getting farther and farther from origin. That does not look like what I would have expected it to do. It did not reset the distance. It says there were 5 total shifts. Well, there the distance changed. Let's just see if I fly. Oh, I see jitter. And that looks like it's because my absolute distance is negative 49,000. So this is the issue I'm trying to solve, not cause. And I think because I jumped 5 times. Let me reset my position. If I can. That doesn't seem to do anything. It doesn't change the Z axis. I think that's part of the problem. My shifting seems to be happening on the X and Y, but nothing on the Z. Oh, it is. All right, let me explain this problem to Bezi. Let's see what it thinks about this. What it is triggering. Oh, I see. I'm moving the ship 10,000, but it's not triggering the actual shift. So it didn't do the origin update. Aha, it's only shifting root game objects, but the player is likely a child of a parent object. Yes, add some better debug logging. It's a good idea. So right now it has a jump button that moves my ship 10,000 units, and then it should automatically trigger the shift. But they're adding an additional button where I could just manually test shifting. Ooh, fancy. So right now I'm not seeing any jitter. I think I'm starting to see jitter. Let me do a force shift. Still seeing jitter. It looks like things did not shift correctly. All right, still not working. Oh man, that's painful. I think I should turn off logging for the object pooling, because that's really, really cluttering up my console. I'm going to do that again. So if I go to Pool Manager, disable that, disable that. Okay. Let me just do another test. Have a cleaner log this time. And I'm starting to see the jitter. And I still see the jitter. All right, Bezi, examine the logs. And we got a few minutes left before I need to cut this short and go back to work. Aha. Player manager. I think what I might suggest it do, maybe in the next session, is let me assign what objects should be shifted in the inspector instead of having it just say, oh, I'm going to grab all root objects and shift them. Because that just seems like it could lead to problems. I am jittering. After this, I'm going to have to wrap it up. I love the way it says, maybe it's this. Wait. No, maybe it says, oh, wait. Okay. Where are those getting logged? I need to get rid of those log statements. So one thing I'm going to do while it's working on that is I'm going to create a branch. So now I'm working in the floating origin system branch, and I can work on this independently, and if I get it working, I can just merge it back into my other branch. And if for whatever reason this approach doesn't work, I'll just throw this branch away. But this will allow me to commit changes without breaking my main game. That's true. Last test. If this doesn't work, we're just going to wrap it up and we'll pick this up in the next stream. It's still not working. Yep. Oh, well. We'll have to pick this up in the next stream. But it's getting there. For those of you that tuned in and watched, thank you for watching. If you like this, click the like button, click the subscribe button, and the notification bell if you want to be notified the next time I go live or post a video. If you have any comments, you can join my Discord server. There's a link in the description, and I'm always happy to answer questions. I'm always curious to see what people think. So don't be shy to hesitate to leave comments. Thanks so much for watching, and good luck on your game development journey.